All right, so we're going to address part D now. Here it says find the x-coordinate of each point of inflection on the graph of f. Give your reason for both answers, for your answers, okay? So we want a point of inflection on the original function. Well, a point of inflection on the original function means the second derivative of that original function is 0 at a point of inflection, okay? So then what happens at the derivative? Okay, the derivative actually has a maximum or minimum, because remember, if you differentiate a derivative, you get a second derivative. And if you differentiate something and you get a 0, then that original thing has a maximum or a minimum. Okay, so where f has a maximum or minimum, f prime has a maximum or minimum, f double prime has a 0. Okay. And then by that reasoning, the original function has a point of inflection where f double prime has a 0. So basically anywhere where the first derivative has a maximum or a minimum, the original function will express a point of inflection. And so that actually appears to happen only here, where we have a sort of a very specific maximum or minimum, right? And we're talking about a maximum or minimum that's like on a curved function and it kind of like goes like that, okay? For example, this won't qualify as a point of inflection. It kind of looks like it's got a little bit of a local maximum or minimum here, but it's too flat, right? So it's not going to be a point of inflection there. All right, so there it is. That's the answer to part D. So the reasoning would be because the first derivative has a maximum or a minimum, the second derivative would be 0, and wherever the second derivative is 0, the original function displays a point of inflection. Okay, there you go.